Thanks, Alexa. That was interesting. So you're in Top Cloud Security Myths Dispelled. My name's Phil Rodriguez. I'm a Principal Security Solutions Architect for AWS based in Sydney. Happy to be back in Canberra for Public Sector Summit.
And g'day everyone, I'm a Solutions Architect based out of Perth. My name's Adam Hunter.
So, we heard Glenn Gore talk about before at the keynote how AWS has a saying where security is job zero. And I'm really proud to work for a company that's always taken security as their top priority and always will. What does job zero mean? It's there at the start of any task list implied. Before we get to number one, we think about job zero, which at AWS is security. And over the last couple years, we've talked to hundreds of different customers around Australia about cloud security. And over time, patterns emerge, patterns of curiosity and trust as customers start to understand what AWS does to keep the cloud secure and what customers should do to consume our services securely. Today's talk is a really straightforward structure. We're going to be talking you through the 13 most common questions that customers ask us about cloud security, and we're going to be answering them from the simplest to the most complex. So curiosity is a really positive attribute, and curiosity is always welcome. And we use some lighthearted terms today. We talk about myths that are dispelled. In a moment, you'll see us say myths that are busted. And don't misunderstand us. We know that these are serious topics. This information could help influence your organization's choice to put sensitive data in the cloud, and it could especially influence your choice around what types of security you want to be applying to your sensitive workloads in the cloud. Over these hundreds of conversations, patterns emerge. And what we see is, for organizations that are new to the cloud, or for IT teams without a lot of cloud experience, they'll ask us about some sort of general security of the cloud questions, as we call them, around the cloud itself. As teams get more advanced and have more experience, they start to ask us more specific security questions about some of our specific services. And finally, especially in large customers and high-threat environments, or with a real strong focus on data security or data privacy, customers and especially customer risk teams will really deep dive with us into a couple of the questions that we'll close today's session on. So we're going to walk through these different areas, 13 in all, and we have a really straightforward format. I'm going to ask Adam a question, he's going to answer, Adam's going to ask me a question, I'm going to answer. We're going to work our way through these 13. Okay, so let's get started. So Adam, the first myth that we want to talk about is customers, especially from an early stage, as they're moving into public cloud, they're just concerned that it wasn't as secure as their private environments were before that.
Yep, thanks. So this is probably a really good place to start. This is a fairly common question for customers who are just getting started with the cloud and just starting to get familiar. And what you see, if you look at the physical security posture of the cloud, what you find is you find the same security controls that you would expect to see in a modern, well-run data center. So you see the same security controls, you see a separation of the network, isolation of the compute infrastructure, and isolation of the storage infrastructure. Now, a bit of a theme throughout the presentation today is that the fact that we do independent third-party audits. Now, that's a really important principle because that means it's not just a matter of what Phil says or what I say and you taking our word for it. That means there's actually evidence to back up and there's audits to give evidence to the fact that these things are actually occurring. Now, on top of the physical security that you get with the cloud, one of the key benefits of moving to the cloud is this concept of visibility. And by visibility, what we mean is that you can see everything within your environment. So all of your resources, all of the events, all of the activities, and really, quite uniquely, all the changes over time. So this is actually quite a powerful concept. And then, but if we have all this visibility, how can we leverage that? Well, a simple example would be, if you go into the traditional on-premises world with a data center, if an engineer visits that site and makes a networking change or a cabling change or does some work on a server, traditionally very little of that activity would be logged. So if we translate that same activity to the cloud, with AWS CloudTrail, all of that activity is logged. So we know who makes what change, when they make it, and from where they made it. So this is kind of game-changing when you're looking at the security model for your infrastructure. So how can we sort of leverage that even further? So we can leverage that further through automation. So almost all of the services and features on the AWS platform are available via APIs. So an API is an application programming interface. That means we can write scripts or computer code to manipulate the whole platform. So if you talk about that scenario that we had before, where someone makes a change, we can do automated remediation in near real time. And this is extremely powerful, this combination of visibility and automation. So, Phil, data ownership. So often when people get started, there's a few misconceptions around data ownership and what happens with that. So can you break that down for us?
Sure, you got it. AWS has a really straightforward policy around the ownership and control of customer data. You, as a customer, are always in control and always own your customer content inside of AWS. We give you a few different tools in order to do this, but we have a very simple policy where we will not access your customer content or move your customer content outside of the region of your choice without your explicit permission. This is a very important principle and relies back to a lot of things, especially around data sovereignty. We'll never access your content without your permission. For example, we'll never use your personal information for marketing or advertising purposes at all. And when you choose to put your customer content into an AWS region, for example, the Sydney region here in Australia, AWS will not move that content outside of Australia without your consent. The way that you control this is through a service that we have called Identity and Access Management, or IAM. It gives you the ability to create sets of users and groups and roles to apply permissions of how you want your data to be accessed by your users and which other services you want to give permission to be consuming and touching this customer content. There's a lot of granularity here, and we're going to touch on identity and a few other points. And it's a really important concept, because in the cloud, your access model is different than you were used to. On premises, you used to create a set of infrastructure and install applications on it, and then give other people access. And in the cloud, it's the opposite. You get access to an environment through which a set of virtual applications, you commission infrastructure. So who you give access to and how you control that access is a fundamental security principle in the cloud. You want to be able to audit this access as well, and we have a few mechanisms that you can use to do this. The most common is AWS CloudTrail, which is our ubiquitous logging platform. Adam talked about API calls, and those API calls are surfaced inside of CloudTrail, which is a record of the activity throughout your users and accounts and services and systems that are especially interacting with your customer data. We enable CloudTrail by default for all accounts and all services for 7 days. And if you want to store this information, all you need to do is just configure a location like an S3 bucket for these logs to be saved for longer than 7 days. Okay, next question. Some customers have a concern that they've been in a highly regulated environment and they can't use the cloud because of some specific compliance reasons.
Thanks, Phil. So AWS has millions of active monthly customers. And out of those millions of customers, many of those are in the most highly regulated industries in the world. So healthcare, financial services, and of course the public sector. And the reason why that those customers can move to AWS is because when you move to the cloud, we can help you meet your compliance regimes by leveraging our global assurance compliance programs. So AWS is certified in over 50 of the world's most common global security certifications. So some examples of that are ISO 27001, which is our information security management system, ISO 2717, ISO 2718, SOC 1, SOC 2, you get the idea, and on we go. So similarly, PCI DSS allows you to store and process credit card information on the platform. So on top of the global security standards that we have, we also have regional security standards. And that allows us to meet country-specific requirements. So it doesn't matter whether you're in the US or the UK or Singapore, and for us, of course, we care about right here in Australia. We have compliance regimes to allow our customers to operate in those regions. So for instance, here in Australia, we have the Australian Signals Directorate, or the ASD, and we've been on the ASD's Certified Cloud Services list for quite a few years now. We've recently just updated our IRAP document that allows customers to evaluate workloads at the protected level, with 46 of AWS services in scope. In the financial services industry, we've recently released a white paper for APRA, which allows you to get guidance about how to run regulated workloads on the platform. There's also the option of an enterprise agreement. So an enterprise agreement allows customers to tailor the agreement to their needs. Now, often this is centered around a specific compliance requirement. So if you're in the audience and you have a specific compliance requirement, please come up and talk to Phil or myself after the talk, or someone out in the expo hall, because we've got options that can help you. So myth number 4, Phil. PII, or sensitive personal data. There's often misconceptions about what you can do with personal sensitive data. Can you bust that one for us?
Sure, you got it.
Cheers.
So encryption is your key control to handle sensitive and/or personal information in the cloud. And I love to talk to customers about our encryption services because they've really changed the game by making encryption a default function of the cloud that you can take advantage of. There's a number of different ways to enable encryption in transit as the data is flowing across the network, or encryption at rest as the data is written to disk inside of the platform. For example, 2 storage services of ours, Amazon S3 for object storage, or Amazon EBS for block storage, both have single checkbox configurations to automatically apply encryption at rest to all of your data that's stored there for free. For customers that want more control over their encryption keys, we offer different forms of encryption services as well. A really good example of this is Amazon Key Management Service, or KMS. Amazon Key Management Service is backed by hardware security modules and been validated to strict global guidelines. And it's meant to give you full control over the keys that you're using inside of our environment. For example, the ability to create or destroy keys and have very specific key permissions to control which of your users can take which encryption actions against which of your storage objects. And all you need to worry about is just those encryption permissions. AWS takes care of all of the rest of the service. For example, we do the hardware maintenance. We will do all of the operational heavy lifting behind the scenes. We do the physical security of the data centers, et cetera. And this allows us to make sure that we're hitting availability targets for the service and durability targets for those keys of 11 nines of durability, 99.9 more nines after that. This is a great way for you to be focusing just on how you want to use those keys and allow us to make sure that that service is available so that the loss of that key is never an availability risk against your data. I mentioned some certification programs. We're really proud that our AWS KMS service has now passed the US government's FIPS 140-2 Level 2 validation, which is new for it in the last year. We also offer a different cryptographic service called Cloud HSM, which is a single tenant environment in which you have full management control over the cryptographic device. And because of that single tenancy, it's FIPS 140-2 Level 3 validated. These are the highest forms of cryptography validation that's available on the market, and these allow you, especially our government and public sector customers, to have a lot of control over how you're encrypting that data in the cloud. Okay, next myth. It can be a little confusing to customers sometimes, too, around security testing, what they're allowed or not allowed to do inside of cloud environments.
So, thanks, Phil. This is a really good one, because this is a common misunderstanding. So, security testing is really important, and let's just bust the myth up front. We would encourage everyone to do security testing on the platform. It's really, really important. And what do we mean by security testing? We're talking about things like vulnerability assessments or penetration testing, possibly even things like static code analysis if you're writing software to deploy onto the cloud. Initially, though, it's worthwhile understanding the shared security model. So for the cloud to be secure, it really has to be a partnership between you as customers and AWS. And the shared security model is an expression of that. And the easy way to sort of understand that paradigm is to think of AWS as responsible for the security of the cloud, and you as a customer are responsible for security in the cloud. So for security of the cloud, what do we mean by that? So all of the servers and all the resources that we need to run the service and operate the platform, we have a responsibility to do vulnerability assessment and penetration testing on those resources and to maintain them and keep them secure. And those compliance regimes I talked about earlier, they actually mandate that we actually do that. Now, in terms of security in the cloud, the customer's responsibility, you're responsible for the resources that you put in the cloud. So that would be things like EC2 instances, RDS, or even API gateway. Now, if you wish to do penetration testing, you actually have to seek approval. The idea is not to discourage people from doing that. It's a very simple online form. You just map out the schedule that you wish to use to do the testing, the resources that you're going to test against, and where the tests will be coming from, and then you can perform the security testing. Now, obviously, for some sort of workloads and some situations, that doesn't work too well. If you're using like a CI/CD pipeline or some sort of DevSecOps approach, and you want to do an automated routine penetration testing, that approach won't work. So we have an alternative there where you can go to the AWS Marketplace and you can get pre-approved tools. And you can take those pre-approved tools from the AWS Marketplace and you can deploy them in your VPC, your virtual private cloud. And then you can use those tools in your VPC to do security testing whenever you want. So, Phil, that's the first 5 of the most common security questions that we get. We're just going to dig one level deeper now and go into the service-specific questions. So the first myth, we've just talked about vulnerability assessment, so finding vulnerabilities, and obviously they need to be patched. Often there's misconceptions around who's responsible for that.
You got it. And we do see some customers confused around which things they're responsible for keeping updated in the cloud versus what we're responsible for. So let me try to address this really directly. As we've mentioned a few things based on our shared responsibility model, when you as a customer are choosing the operating system that you want to run inside of, for example, our EC2 virtualized compute platform, then because you chose to use that operating system and you are the ones that manage that operating system, you have the responsibility to keep it patched. We strongly encourage, if you're using Windows or Linux or another operating system, to use that OS's built-in update functionality, especially if it's going to be in a longer-lived environment, to apply security patches and update security configurations at least monthly, which is best practice. We've got other customers that choose not to have long-running environments, but choose to create ephemeral environments, which are constantly rebuilding many times a month or week or even per day. When you're doing this, making sure that you're starting from a known, patched, good, secure base image, and to be updating from there from a constantly patched source. So I'll clarify that with an example at the end. We've got a couple ways that we can help. One of these is Amazon Machine Images, or AMIs, which are often the basis that customers use for the operating systems that you want to run inside of EC2. We keep those updated as a starting point for you to use. For example, for Windows, the second Tuesday of the month is called Patch Tuesday, and within 5 business days of Patch Tuesday, we will have updated the Windows AMI that's available for other customers to use as a basis for their operating systems. We've got other tools to help as well. Amazon Inspector is our vulnerability scanning tool, which identifies vulnerabilities at the operating system and application layer, which you can use as part of your standard security testing process without pre-approval because it's an Amazon tool. And Amazon Systems Manager is a great, fully automated command line-based tool that allows you to apply a lot of updates inside of an operating system environment, for example, with patching. That's a great way to build on the concepts of DevSecOps that Adam just mentioned and fully automate both the detection of the patches and the application of these patches inside of your dynamic environments. Now, there's a number of services that Amazon runs, which are what we call managed service. And what a managed service means is we take more responsibility for the operational updates and security of the underlying infrastructure that powers that service. Really common examples of this are, again, S3 for object storage, perhaps Lambda for serverless code execution, or RDS for a relational database service. We are responsible for patching, in that case, the operating system and the application functionality, and even the code execution environments, so that you can just focus on the compute or the database or the storage needs that you have, and allow us to do the heavy lifting to keep it up to date. So a really simple example, if you want to install a database, you could choose to do that on EC2, and pick an operating system that you choose to install and put, for example, MySQL on top of that. And then please do patch, because it's your responsibility, the operating system and the database application. If you choose to, on the other hand, use our RDS service, which is a managed service, in our MySQL variant, we're responsible for patching of the operating system and the database application itself. The first gives you a little more flexibility and complete control over that environment. The second one allows you to base our expertise around operational availability to keep that environment up to date. Okay, next myth. Some customers are concerned that just because they're putting data into the public cloud that everybody can get access to it. How would you address that?
Thanks, Phil. So let's use Amazon S3 as an example here. So S3 is a popular storage service, so you can put spreadsheets, documents, basically any file you want, and you get extremely high levels of durability. Now, Amazon S3, like all the Amazon services, uses secure by default settings wherever possible. So in the context of S3, what that means is if you create a bucket, and we have collections of files, we call them buckets, if you create a bucket in S3, then that bucket is private by default. In fact, it's only accessible by the person who created it. So if you wish to create and make that bucket public, you need to go through a series of steps. Within the platform, we have AWS IAM. Now, IAM is Identity and Access Management. That allows you to control who does what on the platform. Now, within the context of S3, you can create roles within IAM, which can completely prevent users from creating public buckets. So S3 enables buckets that are private by default, and you can use IAM to completely lock down your environment so you can't even create public buckets at all. Now, if you actually wish to go ahead and create a public bucket, then you need to go in, log into the console, find the bucket, you need to click on the permissions, and you actually need to explicitly override the default permissions. Now, at this point, you'll get a series of very obvious and bold orange warnings that if you make that bucket public, that it's going to be readable by everybody in the world. Similarly, if you want to figure out or you want to know how many public buckets you already have, you can log into the console, go to S3, and right at the top in bold, it indicates how many public buckets you have. And underneath that, you have the listing of all the buckets, and for each of the public buckets, it'll say next to it, again in bold, in orange, that the bucket is public. So if you need to know what public buckets you have, it's very easy to go into the console and get that information and dive deep if you need to take some action. Now, earlier we talked about the visibility into the platform and the automation. And this gets quite powerful here when you start talking about security configurations. So, for example, let's say we have a private bucket and a user makes it public. So we can have, and that would trigger an event, a CloudWatch event, which would trigger a Lambda. Now, Lambda is just a function or a code that we can write. And remember I said the whole platform is an API. So within that code, we can interact with the platform and make any change that we like. So if a bucket goes from private to public, we could immediately flip the permissions on that bucket. We can enforce a policy to not allow that bucket to be made public. We could change the permissions on the user. Or we could just notify the user, notify security teams. I'm sure you get the point. So this means that you get a high degree of automation with the platform that you just can't get on premises. Next, Smith. So, Phil, we hear a lot about secret keys. We get asked about this fairly often, that people are worried about how to control them and how to stop from being able to lose them. Could you bust that for us?
Sure, you got it. So remember before when I was talking about identity and saying that identity is a primary security control, and we gave you a lot of granular access around it? Identity is a very important thing to keep safe in the cloud. So we've got a couple best practices that relate specifically to this. For example, the most straightforward way to protect your identity when you're accessing AWS is to use multi-factor authentication, or AWS MFA, which adds an extra layer of security protection over your username and your password. I'm sure we're all familiar with hard tokens now, these little number generators, or soft tokens like I'm sure some people here have installed on their phones. This is a definite best practice to make sure that if your username and your password is ever exposed for whatever reason, that there's an extra form of security that you're physically controlling to control who can get access to that account. You can apply these to accounts, to specific users, or even to automated API calls, especially for high-risk things that you only want to happen occasionally, that you want some human oversight before they fire. This myth talked about secret access keys being stolen. And the best way to prevent this from happening is to not create a static access key in the first place. The way to do this is by using IAM roles. IAM roles are objects that have a series of permissions that you authorize individual users to what we call assume to get access to these permissions for a limited amount of time, and most importantly, to get a time-bound temporary security credential associated with them. When that action's no longer needed and that action's no longer taken, those security credentials have a lifespan that times out relatively quickly. So even if they're misplaced someplace else, they're not going to be valid anymore. The use of IAM roles and the use of MFA are two of our best practices for protecting IAM. Those are protect functions. So let's talk a little bit about detection as well. We've mentioned a few detection mechanisms already, like AWS CloudTrail. The one that I wanted to call out right now was Amazon GuardDuty. Amazon GuardDuty is a relatively new service for us, launched in last year. That's our automated managed threat detection platform that has visibility across all of the account and service activity that you're using. I like to think of it as an AWS cloud infrastructure-focused intrusion detection system. For example, it will raise an alert if it sees an IAM user attempting to log into the AWS console from multiple places around the world simultaneously. We have a lot of visibility around the internal workings of the platform. Again, because it's all an API call, there's a lot of granularity in the logs. And we use this as a basis for the security triggering that we manage and give you just the alerts that we think are most important for your environment. GuardDuty is a really popular service for my security-conscious customers in town. It's got a 30-day free trial associated with it, so you can really get a good sense of what it does. So I do encourage you to check it out if you have not already. Okay. Next myth, the concern that some customers have, busted, there we go. The concern that some customers have that, how do they confirm that when they issue a delete command, like for example through the console, that the data is actually deleted?
Thanks. So when we talk about delete on a platform, we need to think about it within a logical context and a physical context. And from within a logical context, it depends on the service. So if we take a service like S3 or DynamoDB, when a user executes a delete call, we actually remove the identifier that links to the data, and so that data is no longer accessible by anybody. Now, if you take a service like EBS, the Elastic Block Storage, which we use to attach volumes to instances, when you do a delete call, that disk is actually zeroed. So the disk is written over and over again so that the data is no longer accessible. So that's logical deletes. So physically, what we're actually talking about here is the physical media within the data centers within AWS data centers. Specifically, what we're worried about here is the end of life or decommissioning of media, and that data on that media can't get into authorized person's hands. Now here we align with NIST 800-88, and that lays out very specific processes that we have to go through when we decommission data. Essentially, what that means is, in practice is that all physical media at the end of life is physically destroyed within the secure halls of AWS data centers before it leaves. Again, before we mentioned our compliance regimes, and of course, there's no exception here. And the SOC 2 report specifically covers the logical and physical deletion processes, right up to and including the physical destruction of physical media before it leaves the data centers. Now, those reports are actually uploaded into a service called AWS Artifact. And as customers, when you log into the console, you can go to the service called AWS Artifact, and you can actually look up those reports for yourself and access them in a self-service manner. Phil, serverless. It's been around for a few years now, but occasionally we still run into misconceptions about the security sort of model there. Bust that one for us.
Sure.
Cheers.
So serverless is here to stay. For example, we have multiple customers in Australia who are using a combination of our different serverless services to run production applications that are handling sensitive and customer information. The primary way to protect serverless applications is through identity. I can't say identity enough today. I hope I'm repeating it quite a bit. And it's a real shift conceptually, because identity is that primary security mechanism across serverless. So you really need to focus on, for example, AWS Lambda, our serverless code execution platform. All you need to do is focus on the code and code quality that you're putting inside of Lambda, and then be very specific around who you want to get access to that code and which other AWS services you want to allow to be able to interact with that code. All of the rest of the security layers rely on us. So how do we keep AWS Lambda secure? AWS Lambda is built on the good, strong security foundations of the rest of AWS. For example, Lambda runs inside of EC2, and it inherits all of the strong isolations within inside of EC2. When you execute a Lambda function, that executes inside of a container environment that we manage, but that's associated with your account, that runs on top of an EC2 instance that we manage, but that's also associated with your account. Code from different AWS accounts always runs on different EC2 instances. Underneath the hood, we're taking care of authorization and authentication of those requests, and we're also giving you visibility of all those requests, again, through our logging platform so that you can audit this environment as well. This limited attack surface is a very useful mechanism for security. And we're taking care of many other things. For example, we're taking care of the network underneath and making sure that it's properly isolated. But we also give you a choice to interact with this network configuration, if you like, through VPCs, our virtual private cloud networking construct, or security groups, which is analogous to a firewall. We're also making sure that all of this information, as it flows between the services, is encrypted and is authenticated. So that allows us to be doing, for example, patching and patch management. We patch the operating system. We patch the application. We patch the container environment, and we even patch the execution runtime environment so that all you need to worry about, which is an important principle of the software development lifecycle, is the quality of the code that you're uploading into Lambda, and then who you want to give permission to execute it. Okay, that was 5 basic cloud security questions that we get. That was 5 more very service-specific questions, and now we're going to get to the 3 most complex areas that customers ask us about security. And here's a good one. Concern that customers have that the government can access their data at any time.
Cheers, thanks, Phil. So right at the beginning, Phil mentioned that security is job zero, and I think this philosophy applies to customer privacy. So AWS never discloses customer data to government agencies unless it's required to do so to comply with the law or in response to a valid and binding legal order. Government agencies and legal authorities need to follow specific legal processes in order to establish those orders. And when we receive them, we review them, and we object to overly broad or otherwise inappropriate requests. So AWS has got a track record of pushing back, and we've repeatedly challenged government subpoenas for customer data, and we've actually been winning cases that have set the legal standards for customer privacy. Unless we're specifically restricted from letting customers know, or there's clear examples of illegal activity on the platform, we'll inform customers before disclosing their data, and this allows customers to seek protection. Fundamentally, this is also a really good point to reinforce the encryption story. Encryption is the fundamental control that allows you to protect your data. Before, we talked about how you can manage the encryption keys yourself. You can use even architectures where you have an on-premises hardware security module. Fundamentally, if you encrypt your data and someone gets access to your data and they don't have access to your keys, that access is completely meaningless. Phil, so the malicious insider, someone can use their administrative access to get access to customer data.
Sure, you got it. At AWS, we have another very important security principle, which we talk a lot publicly all the time, which we call keep humans away from data. Why do we want to do this? Well, the more chances that a human administrator has to access services that have access to customer content, the more of a chance that there is for them to make a mistake. We would not be able to have scaled our global platform if we relied on manual intervention from humans to be keeping it operational. What we do is we rely on a very high degree of automation in order to make this thing that's really changed a lot of the technology landscape. And when we need to update this automation, we create other sets of automation to update the automation for us. Again, keeping humans as far away from that data as possible. Now, there are occasional exceptional circumstances where a human administrator, to fix a mistake, a bug, has to log into one of these service environments in order to update a service exceptionally. And we have a series of technology and process controls to make sure that we're doing that with the right level of protection and oversight. For example, no one with access to the AWS physical data centers environments has access to manage the services themselves, and vice versa. People with access to manage the services aren't allowed physical access to that environment. That service network is entirely separate from the Amazon corporate network, and administrators who need to access the services network do so via a separate set of credentials. When they need to get access, it's done so via a ticket. and they have to use an authenticated, encrypted tunnel with a specific certificate-based access on the far side using that multi-factor authentication we talked about before. This is done through our privileged access management system, and all of the activity that's done during that time is logged, and those logs are made available to our security team for review. And after they no longer need access, they're not able to get it again unless they go through another authorization process. The process controls are really important as well. First of all, human administrators, well, I hope they're all human administrators. The human administrators on our side have to go through an HR background screening process. They have to, like I said before, get access to this ticket, which does have a high degree of oversight. When a human does have to take this exceptional access, it triggers a mandatory review process so that we can make sure that we're creating new automation to limit this human access in the future. All of these things, again, as we're going to say a few times today, are evidence in our SOC reports with all of these statements there and that have been audited with a specific person who checked that control at the specific time, what the results were, and we make that information available to all of our millions of active customers around the world. Okay, last one. I'm glad you got this one. Some customers are concerned that despite all these technology controls, another customer can get access to their data. How do we talk about that?
Thanks, Phil. So we have a saying at AWS that there's no compression algorithm for experience. And for over a decade now, we've been running, managing, and securing a multi-tenant cloud infrastructure. Now, the core part of that infrastructure is obviously hardware and virtualization software. And that's what allows customers to take advantage of our scale to run the operating systems that they want on the instances that are right size for their workloads. So we run two hypervisors. The first one is the open source Zen hypervisor, and the second one is our Nitro hypervisor, which is based on the KVM code from the Linux kernel. Now, since day one of EC2, Zen has been a key core part of our virtualization infrastructure. And going forward, Zen will continue to be a key part of that infrastructure. We were founding members of the Zen project, and beyond having a very deep understanding of Zen and how it works, being a member of the project also means we get early advisories, security bulletins for issues that may affect AWS customers. So that's important. That allows our engineering teams to assess those advisories and to see or determine whether there's going to be a customer impact. And if there is a customer impact, they're able to make a fix in a way that's non-disruptive. If you follow these advisories over time, you'll notice that quite often it simply states that that AWS customers are not impacted by the advisory. So there are several reasons for that. The first one is we actually run a modified version of Zen. So we remove a lot of features from Zen that we don't actually need. Further to that, we actually take a number of the software functions from Zen and actually move them into our own hardware. So AWS is innovating not only at the hardware level, but also at the software level. So with our Nitro-based hypervisor, which is based on the KVM code out of the Linux kernel, all of their storage and network processing has actually moved from general-purpose software into hardware. And our latest generation C5 and M5 instances are specifically designed with the Nitro hypervisor to take advantage of the Nitro hardware. So what does that mean for you? So that means that you get superior performance. You also get a superior isolation between the management data plane that we operate to control the hypervisor and the guest operating systems that you run. All of the services, the compute services, the storage services, the network services, allow you to deploy isolated environments so that your data is completely secure and is not able to be accessed by anybody else. EC2 allows you to provision completely isolated instances so that a process in one EC2 instance is not able to access a process in another EC2 instance. Memory is not shared between instances, and when an instance is terminated, memory is scrubbed before it's then made available to other instances. Similarly, with the network, we have logical separation at the network layer, and that's provided by our VPC, a Virtual Private Cloud data plane. Now that provides a fundamentally logical network separation layer so that the networks are not vulnerable to attacks like MAC address spoofing. Earlier, we talked about the delete process and the fact that data is wiped before it's made available to other customers. So you can see that there are many sort of logical and physical layers and controls in place to ensure that your data is kept safe. The final sort of point to make here is that it's not a matter of taking Phil's word for it or my word for it, that we actually provide evidence that this is the case. And this is in the form of all the global compliance standards that we talked about earlier. A really quick example of how all this sort of comes together at scale from a security perspective is the Spectre and Meltdown vulnerabilities that were released earlier in the year. They were actually announced a week ahead of time. And when they were announced, AWS was most of the way through patching the platform. Now, within 24 hours of that early announcement, the final single-digit percentage of patching was done across the AWS network. And with that, I'll hand over to Phil.
Great, thanks, Adam. That was great. So that was the 13 most common security questions that customers ask us, from the simplest to, as you can tell by the last two there, the most complex. We've touched on a lot of these security benefits. I just wanted to pull them together here so you could see in a single slide our latest thinking in this area. We've designed the platform to meet the security requirements of our most security-conscious customers around the world, and we have a very strict global, regional, and country-specific compliance program to make sure that we're doing what we need to do and proving what we need to do to our customers, that we're keeping our responsibility for security of the cloud. All of these services are built to be highly automated, and this is a distinct benefit to the security community, who's able to now automatically be protecting these environments, automatically being able to detect malicious activity or suspicious activity, and most importantly, automatically being able to respond at scale to any incidents inside of this environment. I think the one benefit I didn't already call out at some point was our large third-party partner network. And that's evidenced out here in the expo hall. I'm sure you've been through. If not, take a look afterwards. And you'll talk to some of our consulting partners who focus on security and also our technology partners who focus on security. So we're back to where we started. Security is job zero. And I hope you have a better understanding of what AWS does to keep the cloud itself secure. And if you do me a favor and help me scale this message. If you understand it, tell your colleague. And if your colleague understands it, why don't both of you go and tell your boss? And if you, your colleague, and your boss understand it, go and tell your CEO and get them to understand that the cloud is secure. And we've got a great new website to help you do exactly that. It contains very straightforward language around how we keep the cloud secure and is especially meant for chief executives or agency heads who are looking at a move into cloud, and talks about data privacy, our shared responsibility model, and a few other things that we talked about today. I'll keep it up for a second because I see some cameras. Nothing worse than the slide going away while you're halfway through the picture, right? Great. So we just wanted to close on this quote, which we like a lot. I'm not going to read it to you. You can do that yourself. I want to reinforce that, as always at AWS, security is a shared responsibility. We take our responsibility for securing that foundational infrastructure very seriously. It's literally our top priority and always will be. We hope you understand what you need to do in order to be securing the services that you're consuming and how you're choosing to configure those. This is not the end of the conversation, it's the start. We really encourage you to continue to learn and access, for example, our great public documentation around this, and continue to be curious and come and ask us questions after this talk out in the expo hall whenever you'd like. Help us work on this together. Thanks very much for coming to the talk today, and thank you very much for helping us keep the cloud secure.